solution.
Instant film was a trend that swept the nation during the late 1900s and is still widely popular today.
Polaroid Corporation was a major manufacturer of instant film cameras and was founded by Edwin Land in 1937. One of the earliest models was the Polaroid Automatic 101. It featured an automatic print of the picture after it was taken.
Land's aim was to make the product more consumer-friendly, but what the consumers did not know is that there's actually a lot of chemistry behind the easy-to-use instant film.
The chemistry behind instant film includes organic chemistry, ionic compounds, bases, quantum chemistry, and solutions.
For example, alcohols are present in the film through its dyes. A hydroquinone dye is a solvent that diffuses a potassium hydroxide. This is its solute. That dye is an alcohol called phenol. It's an alcohol because it has an attached alcohol functional group in its molecular formula. In the complete structure, it shows how it's aromatic. This means that most of the double bonds are presented in its circular structure.
The film itself is made up of ionic compounds. The resulting dye molecules can diffuse up through the light-sensitive layers wherever their corresponding silver bromide molecules are not exposed. This means that silver bromide dissociates and becomes free-floating ions. This ionic compound contains cations and anions. Cations are positively charged particles and anions are negatively charged particles. Bromide is the anion and silver is a cation. Their opposite charges attract to form a bond so that the instant film is made up of a unique compound.
The solution is a homogeneous mixture in which the components are uniformly intermingled. When the silver bromide in the instant film is not exposed to light, it is dissolved by other components in the developing solution, for example, potassium disulfate. Since the silver bromide is what is being dissolved, it is the solute in the solution. Silver bromide is a polar compound. According to like dissolve like, given solvents dissolve solutes with polarity similar with its own, meaning that silver bromide dissolves its polar solvent with the polar solutes in the camera. This is why it's called the Polaroid picture.
Bases are formed onto the film. The film contains a plastic base that is covered with particles of a silver compound. The process of photo development in the camera onto the film ends when potassium hydroxide reaches the timing layer. The timing layer is just one of the layers in the film. In this layer, any leftover potassium hydroxide is neutralized because it is a base. Base is neutralized from acids that are presented in the film to form water and salt. This means that acids donate a hydrogen to the base because bases are hydrogen acceptors.
Since the film is basic, it has a high pH. A high pH is anything above a 7.00 on the pH scale. These basic qualities are what is needed for instant film to work efficiently. In quantum mechanics and in chemistry in general, electrons determine the chemical properties of atoms. This was evident by Bohr, who concluded that electrons occupy specific energy levels in atoms. Those energy levels are the ground state and excited state. When electrons move from state to state, they give off electromagnetic radiation. This allows a specific color from red, orange, yellow, green, blue, violet, and indigo color spectra to be seen. Quantum mechanics ties into instant film when the silver bromide compound is exposed to a large number of light photons. Photons, defined by Albert Einstein, are lumps of energy that make up light. The visible light allows the picture to be exposed onto the instant film. According to visible light, the longest wavelength is red when the shortest is purple. In the film, there are different layers of colors. When the picture is exposed to white light, the chemicals allow the dyes to reach certain levels to form the picture and allow some of the colors to be seen.